Tessa. Testing, testing.
Yes.
Testing, testing.
Are you going to do it?
Oh, quicker. 这个可以用吗？啊？ All right, good evening, ladies and gentlemen. If you guys would take your seats so we can begin with the first speaker. All right, very good evening to all of you. My name is Sean, the founder of the Ethereum Singapore Meetup Group and a co-founder of Digix Global, an Ethereum startup that tokenizes gold on the blockchain. It's my pleasure this evening to introduce to you two speakers. Firstly, Chris Hitchcott from Digix and Andrew Keys from ConsenSys. I believe Chris is a familiar face to most of you who have attended the meetups in the month of March. Chris brings with him a wealth of experience in depth and web development. He will be speaking on the Digix tech stack and the use of Truffle, an Ethereum development framework by ConsenSys. So without further ado, let me allow Chris to start his presentation. Thank you.
Hello. Thanks everyone for coming, and hello internet. There is a live stream. Just get my slides up. Okay, hi, so thanks for the introduction, Sean. My name is Chris from Digix. Today I'm going to be presenting on the Digix tech stack, which does include Truffle, but it's not particularly about one specific technology. I wanted to just touch upon everything we're using, basically, and try and impart some knowledge to potential new app developers. We are an Ethereum startup using Ethereum, so hopefully this will be useful to some people. So first of all, what are we doing at Digix? As Sean mentioned, we're an asset tokenization platform. Essentially, this means turning real-world physical gold into tradable tokens on the Ethereum blockchain. We do this using what we call the proof of asset system. It's a smart contract system using Ethereum. We also have a marketplace app, which is just a traditional front-end web app. And finally, we have a real decentralized app as part of the back-end transaction signing tool for the various parties that are involved in POA. For example, auditors need to sign transactions to prove that they've audited things, and that gets registered on the blockchain. So very briefly, how does POA, proof of asset, work? We basically have three parties: the vendor, the vault, the custodian, and the auditor. Each of these parties are responsible for verifying the existence and the ownership of the gold, and every quarter, the auditor will come in and make sure that all the gold is where we say it is. And of course, this is all published on the Ethereum blockchain and is immutable in history. So, how do we do it? Basically, there are four main layers to it. Of course, the smart contract system itself. I'm not going to go into detail about the code, but I just wanted to talk about some of the general patterns that we're using that you might find useful in your applications. We're using Ethereum and a thing called IPFS, which we'll go into. And we have a DevOps stack for helping us write and deploy and test our contracts. That includes Truffle. And finally, I'll touch on the front-end platform, which is a product called Spectrum that I've been working on. So first of all, I wanted to compare the traditional web stack as a kind of useful sort of visualization of how you might do it in a traditional web world. You would typically have a database and a application server that developers can reach into and update and push new updates to. There would then be, on the user side, a front end that has some sort of gateway between the application and the user. And the devs also have their own language choices and testing frameworks, etc. In the Web3 stack, it's slightly different. essentially devs and users have the same access to the blockchain. So you need to kind of design slightly differently about how you interact with these different layers. I'm going to go through in this presentation all of these points, not in detail right now, but we'll go through as we continue. So first of all, smart contract patterns. The idea of a pattern in programming is just essentially a concept that's generally used across multiple different languages and helps you design things in a robust and secure way. I was lucky enough to attend a talk last night by Mr. Antonopoulos, who coined this term trustware. And the idea is that you have software that has the properties of hardware. So if you deploy a smart contract on Ethereum, once it's deployed, you can't recall it. It has the properties of hardware in the sense that you have to be very meticulous, design it beforehand, and properly deploy it and make sure it doesn't go like this. This is the Samsung Galaxy Note 7 that blew up. So don't deploy this on the Ethereum blockchain. One of the first patterns that we're using is the ICS pattern. This is Interface Controller Storage. It looks a little bit like this. And basically, you have various different contracts with self-encapsulated functionality that are very easy to test, small amounts of code, and they have various roles. So for example, the interfaces. Each contract would have a set of methods that can be called. For example, a custodian would call, I've received this asset. A vendor would say, I've sent this asset. And the auditor would, on a quarterly basis, send a transaction saying, yes, this is where it's supposed to be. These interfaces then talk to the controllers, which are the business logic of the application. Now, these basically deal with where the data flows, who can make transactions, updating the storage layer, and then the storage layer is what holds the actual data. So the ledger itself will be stored in these storage contracts. Now, the beauty of this pattern is that you have very small testable units of code. You have potentially baton-hardened small units that can be deployed in multiple different applications. And because they've been used before, you know they're secure. You can import them into different code bases, including various different projects within the Digix stack itself. And then finally, most importantly, it's upgradable. So you could, in theory, have an on-chain vote to replace the relationship between the different contracts. And that gives you a decentralized upgrade path, even though you've deployed in a kind of trustware scenario. The next pattern is CACP. This is the access control pattern. Effectively, it's a permission system where you can assign users into groups, and each of those groups have different roles, and they can essentially own various parts of the application and have permission to execute transactions. If you combine them together, ICS and CACP, you get something that looks a little bit like this, with very small modular pieces that have been battle-tested and hardened that can come together to create a much more complex system than the sum of the parts. So, the back end. We, of course, have the marketplace app, which, think of it like Amazon, really. We're just selling directly to customers who go through a KYC process, know your customer process. And this has to be centralized because of privacy concerns. We don't want to publish all of our customers' information on the Ethereum blockchain. So it's just a traditional web app with a Ruby backend and a relational database. The more interesting part for me is the decentralized part, which includes Ethereum and IPFS. So IPFS is a service, basically allows you to upload generic media and has a relatively strong assurance that the media is going to remain. It used to be called permanent web. It's not quite permanent, but there are ways of making it permanent by pinning. It's essentially a combination of BitTorrent and Git and the World Wide Web. And it allows people to have a very strong assurance that the data that they've uploaded is going to remain there, and the integrity of that data remains, because it's all content addressed. Basically, a hash of the data is used to address the data. So when you visit a particular image, for example, you know that the original uploader uploaded that very image, and it can't be replaced because it's hashed. Essentially, the reason for doing this is because if we wanted to store a lot of data on the Ethereum blockchain itself, it would be prohibitively expensive. So we upload generic data into IPFS and then save the hash of that data on the Ethereum blockchain. And that means we can upload as much data as we want for a relatively cheap gas price. Next, we'll talk about DevOps, this idea of building, testing, and deploying. This is not a user-facing system. It's just what we use in-house to help us develop applications. The first topic to cover is that of testnets and the various different methods that you can deploy to, different blockchains you can deploy to. The first in any setup would probably be a virtual blockchain. This would be TestRPC, for example. And this is a very fast fake blockchain that mines blocks instantly, and you can just decide the balances of anyone. It's used primarily for contract testing and should be done as a day-to-day iterative process. Once you have some contracts and they're tested, you write your tests against the TestRPC node. You would then deploy to either a private or a public testnet. And this allows the general public to try out your contracts, interact with them, try and find bugs, and then you iterate again and again using the public testnet. This is especially useful for user interfaces because on a TestRPC node, it's difficult to get persistence. And then finally, you deploy to the mainnet. This costs a lot of money, and it could potentially have a lot more money involved in it. So it's best to make sure you get this right before you deploy. So there is a testnet called Ropsten, and this is the official Ethereum testnet. It's a proof-of-work testnet, and we recently migrated away from Ropsten to a testnet called Kovan, which is proof-of-authority. The reason for that is because a malicious actor had managed to acquire a bunch of ether on the Ropsten network by sending lots of GPU hash power towards it to acquire lots of ether. This, in my opinion, is a fundamental problem of any proof-of-work testnet, because basically the only reason to send GPU mining onto a testnet is to attack it. So basically, in response to that, a group of primarily Singapore-based startups got together and decided to start our own public testnet. And it's called Kovan. Basically, it has a few advantages. It is proof of authority, so it's essentially like a managed testnet by these authorities, these 8 original authorities. And it's because of that resistant to the spam and bloat attacks that had happened on Ropsten. Because we control who gets the ether, we can guarantee that only legitimate developers get the ether. And that prevents anyone from launching an attack in the nature that they did to Ropsten. We provide a few faucet services. Right now, you just join the Gitter and ask us for ether. But very soon, we'll have some automated systems where we approve GitHub accounts and people can get a daily withdrawal. One of the major benefits of POA is that you can have a 4-second block time that's consistent. So from a UI developer point of view, this means that I can guarantee that if something doesn't happen in 4 seconds, my UI is broken as opposed to the blockchain. Instead of having a variable between 10 and, 30-second block time, you get a much more easy to deal with response from the blockchain. And Kovan will also be implementing some of the more experimental EIPs, so it could be seen more as a preview network as opposed to a testnet. But it has a lot of benefits over the Ropsten testnet. The main one being that it's stable. This is Kovan chugging along nicely, currently at block just over 300,000, with about 30,000 transactions. This is just after 2 weeks, so there are a lot of people using it, and it has been a useful thing for the community. So how do you connect to these kind of blockchains, both for developers and front-end users? Well, the traditional way is having a full node on the machine itself that's running locally, and you connect directly to the Ethereum network by having a local service running. Now, this is great for laptops and developers, but in some cases, if you're testing on mobile, there's no solution right now for a web app that can connect to a local node. So the solution is you have what's called a zero client that runs on the node in a JavaScript environment. This zero client is responsible for signing transactions, reading data from the blockchain, and there's a gateway service in the middle that relays transactions and allows people to request data over HTTP. One of the other benefits is that it's instant, so there's no sync time. There are a few other benefits. A is accessible, like regardless of what hardware, if you've got a phone, if you've got a Raspberry Pi, you can instantly connect if you have a web connection. It's more convenient because you don't have to wait and you don't have to install anything. It's redundant, so if your node goes down for whatever reason and you have to upgrade, it's a pain in the butt. So it's better to just have a remote endpoint that deals with all that for you. And finally, security. You can sign without the keys being on the node itself. So in some senses, you can basically do offline signing and relay the transaction to an online machine and then publish it via this zero client. So it has a lot more security flexibility than the traditional local node. We're currently using a service called Infura by the good fellows at ConsenSys. Infura is both supporting IPFS and Ethereum. So for us, it's great because it solves both of those problems. It's scalable. They have load balancing software built in. It's reliable. We've had no problems with it. And at the moment, it's free. So this is a great boon to the Ethereum community. And thank you, ConsenSys. It's great for end users and deployers alike because using the zero client system, you don't have to worry about maintaining a node or even having your end users maintain a node. So they can just connect to a website and start. Oops. OK, so this is our typical workflow at Digix. If we're iterating, we would be doing that on test RPC. So developing the contracts, writing the tests for them, repeating until we get the correct system. Then we deploy to Kovan, which is the testnet that we're using. We do this because it's free, and it doesn't cost us any money to have the public try and battle test our application, find bugs in it. And then finally, well, next we deploy to the mainnet as a beta release, just to make sure, right, and try and get people to attack it on a real non-proof of authority network, on a proof of work network. We test it, make sure it works, and then we do the production launch. So that's our current process. But how do you manage all of these 7 steps? Well, ConsenSys comes to the rescue once again with a product called Truffle. Now, this is the Swiss Army knife of Ethereum, self-proclaimed, and I tend to agree. There are tons of features that Truffle provides. It also has a lot of community support. It's currently the most popular by far, and it recently achieved 50,000 downloads. Congrats, Tim. The benefit of this is that the community will help maintain it, and if bugs are found, they'll get fixed quickly. And also, potential plugins can be built by having a larger group of people that are dedicated to this project. Also, they were kind enough to put our logo on their website, so go to their website and try it out, give it a download. So what does Truffle do exactly? Well, of course, you can write and compile your contracts. You can poke them in Truffle console. So this is a command line interface where you can interact with your contracts using the command line. Importantly, it has an integrated test suite. So this is nice because you don't have to do any setup yourself. You just say deploy contract, and you can start testing the methods, and it will handle all that for you. You can import contracts from other projects. Now, if you think back to the ICS pattern, this is extremely useful because now it means we can separate our code into multiple repositories and import them whenever they're needed. So this is extremely useful for modularization. And finally, it lets you easily deploy to multiple networks. So first of all, the test suite. Truffle supports both JavaScript and Solidity. Right now, we've just implemented the JavaScript because the Solidity feature is quite new, but we will hopefully be implementing tests in Solidity as well. The tests that we are writing are unit tests for the individual pieces, as well as end-to-end test for the whole system. So yes, we can test individual parts, and they work, but when you put together, do they work as well? So that's the difference between these two types of testing. And then finally, we have, because Truffle is based in JavaScript land, we can import other testing libraries like Jest, which is a React-based testing framework that's really good for fast user interface tests. So importing contracts, again, new feature that is, in my opinion, the killer feature of Truffle right now. It allows you to modularize your contracts and import them into each other's projects. You can make those projects public via NPM, and at that point, you now have these modules that are out in public that are battle-tested, and you can import knowing that they are secure. This means you can share code and create a community around it, which is really nice. And it saves the deployed addresses. So if I've deployed like a math library on Kovan, you can import that without redeploying it. You can link it to your contract. And the address is saved within the Truffle package. Finally, deploying. As I mentioned, multiple networks with ease with just a config file. You have these things called migrations, which are like stepped deploys. So you'd have step 1, deploy the migration file. Step 2, deploy your libraries. Step 3, deploy the actual controller interface. And then you could come along later and add additional steps. And because they're stepped, Truffle already knows which things have already been deployed and will only continue the deployment in the last step, which is great for extending your deployment. As I mentioned, you can link from existing deployments. And finally, one of the lesser known but awesome features of Truffle is support for custom providers. So custom providers being how you connect to the Ethereum blockchain. And this is what allows for the zero client deployment system. So traditionally, deployers, developers, would be using a local node without a light wallet in between it, a zero client. But now with Truffle, you can do that, and that's got several advantages. Basically, this is what it would look like before. For each different node you want to deploy on, you have to maintain the keys. If you had 4 different user roles, you have 4 different key stores, and you have to copy each key store into each different client. If you have more developers and more environments, that gets more complicated. If you have a different set of keys for deployment, that gets even more complicated, and it's not really scalable. So with the zero client provider that Truffle now enables, you can save your key stores along with your tests, and this makes it a lot easier for managing these multiple roles across multiple environments. And it also allows you to deploy via Infura, which is previously not possible. This is what a typical config file would look like. You see each different network here with the light wallet provider, which is the zero client, and you simply change the network name to deploy to that network, and Truffle handles the rest. We've also built some in-house tools to kind of extend the Truffle experience for our personal needs. This particular light wallet provider is an extension of the one that comes with Truffle. We added support for key store and passwords instead of just a seed, so it's a little bit more secure in that sense. We added support for changing the polling interval. So because Kovan has a 4-second block time, the default is polling, I think, every 6 seconds. So in this case, we wanted to reduce the poll speed so it would deploy more quickly. There's also a pre-fund option. So with TestRPC, if you have your own key stores and you boot up TestRPC, those accounts are typically not funded. So with this add-on, it will automatically fund those accounts, and you don't have to do any manual funding before you do your tests. We also have a tool that kind of extends on the Truffle testing framework. This is what it might look like in the normal Truffle environment with a series of promises to do tests. It can get a little bit unwieldy and not readable for developers. So we've replaced that with a library called Contest, which is basically an API-driven declarative contract testing framework. And as you can see, it's a lot easier to read. It does a lot of things behind the scenes to create the assertions when transactions happen. And you can do things like watch events, which would otherwise be quite complicated. You need to set up the watchers and do the assertions and create your own logic for that. But we have it bundled into this library. And then finally, we have it connected to the EVM time dilation thing, which allows you to test for time-based events. So in the case of Digix, we have a demurrage fee that increases every day or so. And if you wanted to increase the time one day, it's difficult to test that unless you have a way to like force the blockchain to update the time. This is a pickle. It's actually a gherkin. And if there's any potential smart contract lawyers in the room, this is the kind of script language that you might be getting more familiar with in the future. Basically, the test framework that you just saw could be eventually looking a little bit like this, in a more readable way that you can share with both your management team and your developers so you both are on the same page. Finally, we have documentation generation. Now, there's a little-known feature in Solidity called NatSpec, Natural Language Specification, and it allows you to write basically a description of what your contract and your methods are doing. Right now, it just spits out a JSON file that's not very well formatted. and we went ahead and built a generation library that will spit out a nice-looking website, potentially connected to Web3, so you can even test the methods inside the documentation itself. So here's a quick example of what that would look like. This is a simple send coin method. You describe the whole method in the dev area. It supports Markdown, and each different parameter you define, and it will generate this as the output. Finally, front end. Now, I am not sure if I mentioned this, but I'm basically a JavaScript engineer, full stack JavaScript guy, but I also do a lot of front end, and we're working currently on a new Zero client that we'll be using in the Digix stack. Right now, this is the landscape, and as you can see, there is no single light wallet that solves all of these problems. There's something that they don't get right at some point. So fundamentally, we wanted to create something that solved all those problems. Yeah. So the reason we're trying to create this kind of platform, this user interface, is for not just the current asset tokenization platform for signing transactions, but also for future governance mechanisms and future dApps. So yeah, the main 3 points that we did this was to tick every box to make sure our users had the full suite of user experience that they could have. We wanted to create a standardized user experience and UI. That means the actual components that are in use. It's kind of like switching from MySpace to Facebook, where you'd have like a dApp that someone else built online that has a weird interface. Now it's all standardized in Spectrum, and this is what will allow people to have an intuitive understanding of the apps they're dealing with. Finally, technical debt. Essentially, we wanted to create a platform that allowed us to rapidly develop and iterate on user interface. So creating a platform that solves everything and makes a nice developer experience will help us more quickly iterate future applications. And we called it Spectrum. We called it a light suite. Basically, this is a dApplet platform. It's a light wallet with a dApp store built into it. The idea is that everything is as modular and configuratable as possible by the end user, be it networks connecting to any network they want, key stores, various different types of key stores, including offline wallet, UPort, V3 wallets, and custom storage providers for syncing with a Dropbox or Google or whatever, IPFS even, and encrypting it, of course. Finally, we have the dApp store, which is essentially Spectrum provides all the tools that a front-end developer would want in order to easily create a user interface. And this is what a dApplet might look like. This is the latest release of Spectrum. This is the Networks tab. This is the key stores. You can see multiple different types, pulling the data from Infura. This is the first dApplet for Spectrum, which is the POA, proof of asset, interface for vendors and custodians. They can register new assets, upload the file to IPFS. This is an actual decentralized application, so there's no servers involved. It just connects directly to either your local host node or Infura and an IPFS service. They upload the document, and you can see the IPFS hash there that we save on the blockchain. They sign the transaction, and then it gets added to the blockchain. So this data is actually in the blockchain, but the document is not. It's just a hash of the document. So the way that we're making this properly decentralized is by leveraging smart contract registries. Now, the general idea is that just like with the IPFS image, you can do the same thing, but for applications. So parts of what we call dApplets, these little pieces of code, you can upload to IPFS, hash them, and it looks like this. Basically, you would have, for example, this V3 key store plugin that you then bundle. You push it to IPFS, and then you register the hash, and then Spectrum can then download that bundle. So you have a fully decentralized app store within a web browser without any downloads, as in no native app download. So in summary, this is our stack in very simple terms. Thanks to Truffle and Infura, we're able to iterate a lot quicker. and we'd have to build these out ourselves and maintain it ourselves had it not been for these tools. So it's super useful to have. It's kind of like working your way through a forest and someone hands you a nice, shiny, sharp machete. It's a really useful tool to have, and it has helped us tremendously. So thanks. That's it. Do we have time for questions? I think 5 minutes. We're giving away free Digix stickers if you ask a question. So they're each worth 1 DGD. They're not really.
What does it take to get a Digix sticker?
Not much. So there you go. Yeah?
You are speaking and thinking based on the talk last night about the battle-hardened software we need to build so that when it's delivered on the blockchain, it cannot change it, it has to be as strong as possible. We already know from the cryptography environment that very battle-hardened primitives, crypto primitives, can be modularized in a very wrong kind of way.
Right. So, yeah, I think with the ICS pattern, you can pre-build in logic that determines how things get updated. And of course, you don't want to make it so one guy can change everything. We can potentially connect it to a DAO, right? And the DAO votes on which modules get updated and which ones don't. So you get the same decentralized guarantees, but it still has that upgrade path. Which so far we haven't really seen in the in a trustware environment.
How do we solve having the centralized app for the identity with the blockchain app?
Right. Okay, so in order for us to sell directly and for people to purchase DGX or bars from us, they need to go through this KYC process, which is centralized. At the same time, once they've withdrawn from our service, they can go on the free market, you can trade it on Poloniex. It's only when you come back to redeem the physical gold that we care about who you are.
So does the centralized app also talk to the chain?
Exactly. There's an overlap between the process for creating the bars and all these vendors, but that happens in a decentralized way. It's just when it comes to us as selling directly to end customers, then we have to have a know your customer anti-money laundering scheme. Yeah, if they wanted to withdraw, then they could into Spectrum and they could use, in fact, they don't need to use Spectrum at all. They could use MyEther Wallet or various other services. Oh yeah, stickers. You can get. In fact, I'm just going to leave a bunch there, so if you really want one, go ahead. You can have an extra one if you want. Okay? All right, one quick question. Okay, yeah. First question, difference between DGX and DGD. DGD is a token that can be used to collect rewards, and these rewards are accumulated by the total transaction volume and total volume of the DGX, which represent 1 physical gram of gold. So each DGX is worth 1 gram of gold. People can trade it and use it as a utility token. Second question was about DGX and fiat. No, you can't purchase directly from fiat, but there are payment gateways that you can convert into Bitcoin, and we accept Bitcoin and Ether payments on the platform. Thank you. I think that's time. Thank you.
All right, thank you, Chris. So next up, we have the keynote speaker for the night, Andrew Keys, the Global Head of Business Development at ConsenSys. ConsenSys is notably the largest Ethereum developer studio in the space with project components such as Block Apps, BTC Relay, Infura, MetaMask, and many more. I'll allow Andrew Key to present to us the agenda of tonight, the Enterprise Ethereum Alliance. Andrew, please.
Test. So we all know
Ethereum is the most popular blockchain with respect to developers. There are different metrics, but my estimation is there are about 30,000 developers that are regularly building Solidity-based Ethereum virtual machine compiling smart contracts. That being said, we're seeing tremendous interest from the enterprises. Fortune 500s that have CTOs, that have adults, that have requirements, that have fiduciary responsibilities to be regulatory and compliant, secure, et cetera. And what we've seen is we've seen many of these entities working at the protocol layer, where they're essentially taking Geth, removing mining, and tweaking it. And these are 3 examples. BHP Billiton, the largest natural resources mining company in the world, JP Morgan, and Santander. And basically, I think that's inefficient. We want everybody, for the most part, building at the application layer and having smart people like Vitalik building at the protocol layer. And we thought that that was somewhat redundant, that all of these entities were essentially building and changing the protocol layer. So, I mean, why use Ethereum? You've got open source, widely available. You've got, if you understand JavaScript, you can write Solidity smart contracts. By far the largest, and it's a testament right here, ecosystem. This is happening all over the world. There are the exact same meetups that are 99% attended or standing room only, and it is permeating faster than anything that I've ever seen in my life. We've got the crypto economics of the public chain, and the ability to actually tokenize assets, i.e. Digix Gold. So why the Enterprise Ethereum Alliance? The public protocol, in my opinion, is still in beta. It is basically it has 3 scalability upgrades, transitioning from proof of work to proof of stake, implementing state channels, and then finally quadratic sharding, so sharding the address space where only shards of the environment have to come to consensus rather than the entire consensus, or excuse me, the entire chain. And it still has to implement privacy, implementing zero knowledge proofs. So that's all awesome. That's not finished today. So enterprises with CTOs and adults aren't going to sign off on having all of their code public to the world. And what we believe is this is kind of a half step, an intermediate step, where we can get people still compiling Solidity-based smart contracts, getting used to developing in the Ethereum ecosystem and landscape in permissioned environments. And what we believe will happen is that depending upon your use case, you're going to have business logic that will splay in a private environment, consortia environment, or a completely public environment when Ethereum fully scales out. So also the EIP process is mostly public. We've got corporate users that are tweaking the open source code, and we've got code-based fragmentation, lack of application portability, and duplicated requirements. So Enterprise Ethereum Alliance is an initiative to create standards. The analogy that we use, not the intranet internet, but actually when Java became J2EE, Java 2 Enterprise Edition. The reason Java is developed by 9 million developers around Earth, and this is what we want to do with Ethereum, is because there are standards. There are clean APIs, and developers want clean interactions. So, long story short, we kicked off the conversations about this initiative at DevCon 2. Some of the most renowned CTOs, like Alex Batlin, who was CTO at UBS with respect to blockchain, who's now their CTO at Bank of New York Mellon, Julio Fuara, who is the head of research and innovation at Santander, and a few others basically gathered around Vitalik and said, we want to help complement your vision at the enterprise level. And so we had an incubation at Microsoft in New York in December, and another meeting at Microsoft, and then we had a public release in the US at JP Morgan 2 weeks ago. And so basically what we're doing is we're developing a standard, not a product. This is not, and another thing is this is not a pay-to-play. We're not going to charge $250,000 for you to walk in the door. We're also not going to charge for governance. We're going to have bottom-up technical decision-making that's coupled with top-down administrative paperwork. So if a bank wants to use this technology, they can actually go to a website and understand who is driving these open source specifications and kind of what the process is moving forward. So the other interesting note is that we will always maintain compatibility with the public network. And we are going to leverage other standards. So ISO, Swift, we're talking with W3C, we're talking with IETF. So we want to have strong governance, retain public compatibility with public network, and technical innovation and enterprise-grade governance. So here's the holy trinity of N2Eth 1.0. N2Eth 1.0 is going to be a reference architecture, and entities are able to comply with it. And it's really, the 2017 roadmap has really three main focuses. First one is pluggable consensus. The ability to switch out consensus algorithms depending upon the environment that you're at. So the analogy that I use here is that there is no public HTTP, there's no private HTTP, there's only HTTP. And whether you're in a firewall, in a private setting, or if you're just going onto the internet, you're accessing HTTP. Similarly, we're going to be able to swap out proof of stake for PBFT. And you're going to be able to use the same smart contracts either in a public setting or in a private setting. So the notion of pluggable consensus. Configurable privacy. So rules-based auth-auth privacy. And then in terms of security, and if anyone has noticed Quorum, it is the first time JP Morgan has ever open sourced technology. And really, this is kind of one of the catalysts to this endeavor. They took Geth, they tweaked it, and they had peer-to-peer transactions. So basically, the whole chain doesn't have to see a transaction, just two counterparties and potentially a regulator. So basically implementing the best of Quorum. So again, pluggable consensus, privacy, and rules-based permissioning. We've set up a legal structure. It's a 501c6. We've got core working groups at the protocol layer. They're self-organizing by vertical. So we've got groups working on core retail banking, bonds, what an ISDA agreement looks like for the International Swap Dealers Association, for example, supply chain processes, and we've started a membership model. So everything is going to be bubbling up, bottom up, from the technologists. I think that's the kind of core governance notion. And again, we've got the largest community by far building this technology, and it's just growing even more and more rapidly. Public and private blockchain implementations. AOL, CompuServe, Prodigy, lost. And I think that it's important to have technology where we're considering that the public network is going to scale and it is going to be private. And in my opinion, it is going to be the next generation of the internet. And if you don't want to sync with that, I mean, I think that's a fundamental consideration here. So here are a few of our launch members, or these are the launch members. Obviously, we've got Accenture, some of the best startups in the space, BBVA, British Petroleum, CME Group, largest derivatives trader, Credit Suisse, ING. The Institutes is an interesting one. The Institutes is a nonprofit 501c6 as well that controls basically their members are 70% of the US property and casualty premium and 35% of the global property and casualty premium. So their members are things like Aon, Marsh McLennan, AIG, Intel, Microsoft, JP Morgan, Santander, Wipro's the largest system integrator, UBS. And this is the tip of the iceberg. We had 30 launch members, and we have had interest from over 250 other members since this has happened. And this is going to grow just like the community is growing globally. So, long story short, if you are interested in joining this, you can participate in some of these instances completely for free. There are membership administrative dues as well. If you want to join in kind of a larger level, we can talk about that specifically offline. And I'm here to answer any questions. Thanks. Questions? What is the connection?
Yeah, this is news to me.
Long story short, they've reached out to us, and they are basically, we're figuring out how to have a mutually beneficial relationship. And that's where we're at. So there's a group. Alex Batlin is our technical steering board chair. And there is a technical leadership board. Jeff Garzik, who was Bitcoin core developer, 12 years at Red Hat, board member of the Linux Foundation, is also on that board. There's a handful of developers. From ConsenSys, it's Bob Somerville, Shahan Kachkorian, so he's PhD in distributed systems, worked on the Hadoop cluster, and Bob was at the Ethereum Foundation. Who else? Oh no, it's not a complete rewrite. It's basically that's a good question. So this isn't a rewrite. This is basically cleaning up and standardizing various clients. So we're going to take the Python client and hack that and basically implement pluggable consensus, like kind of the best of quorum, and then have that as a reference architecture, and then that spec can be deployed through any of the clients. Excellent. I mean, I think that what we're seeing is that entities are figuring out how to maximize collaboration and minimize competition in consortia. There's a lot of common costs and common issues that banks, for example, have to incur. And so having some type of standards body around this, what I'm seeing from the banks, first and foremost, is they need the developers, and by far, this is the most robust developer community in Ethereum. And the tooling is used the most, and those with the developers win. Yeah, so I mean, I think initially it's a cost perspective. I think it's the fact that they are paid to provide trust and be an intermediary, and that's what a blockchain does. It reduces the need for trust and reduces the need for intermediation. So there is a consideration that the sole value proposition of a legacy bank is being threatened. Also, you know, their systems are 30 years old. So there's an upgrade cycle there as well. So you're checking off a few boxes. Do I think the banks will quote unquote go away? I do not. I think that there will be use cases for banks. I think that this technology will help optimize their solution. I think that they will be nibbled at. There will be they'll drive their margins down tremendously. But I do think that there are ways to kind of upgrade the database before they quote unquote disappear. I don't think they will. Sure. So I spent November in India. Accenture, Wipro, Tech Mahindra, et al. There will be, estimation from my experience, I think there'll be about 10,000 Solidity developers ready to rock by the end of this year that are all kind of spinning up JavaScript or with JavaScript experience that are spinning up Solidity-based smart contracts. So I think that they, and basically that's being driven by those people's clients. So Accenture is incumbent clientele, and I think that what we're seeing now is the advantage of kind of the general purposeness of Ethereum. That you can use this kind of smart contract generalized platform, and it has that long tail. So I mean, everyone's got incumbent clientele, and they're obviously going to try to go to their incumbent clientele and generate and harvest that business internally. But I mean, what we do at ConsenSys is we basically go to people, or they come to us asking, you know, WTF is a blockchain, and then basically we take them through. This is what it means to the business. This is what it means to the technologists. This is a sandbox, so we can help you get your hands dirty and actually build smart contracts. And then we go through that kind of use case elucidation process, build a proof of concept that's an easy win for 8 to 12 weeks. And then once that concept is proven, we deploy it into production. So the next 6 to 9 months, I foresee this reference architecture spec being improved, battle tested, enterprise grade. That will be ready, I would imagine, January 1, 2018. Then but with all that being said and done, 99% of the enterprises should not be building at that protocol layer. And what we're seeing is that they want to use Ethereum at the application layer. So they're already self-selecting into vertical specific use cases. So even though we're building at the protocol layer, you've got like the genius PhDs that are doing that, and then we've got how to make the proper bond, how to make the proper derivative contract, how to make the proper supply chain, and that's self-selecting on top. And you will be blown away when you see the next group of members that are onboarding. It's kind of the who's who of planet Earth.
When you say it's going to be compatible with the public chain, is the intention that it will be a client, could be a client that runs as a
So exactly. So basically, the notion is that through pluggable consensus, we can use proof of stake, and you turn it on and off like a light switch. So versus the other consortia where they're solely working on private implementations, I think it's missing the point that there is this public chain. It is scaling. I don't think that it's completely mature yet. Definitely not for enterprise type deployments. But when you do have those three scalability milestones completed, proof of stake, sharding, and state channels, and you do have zero knowledge proofs incorporated, you've got a next generation World Wide Web. And if you're considering any type of architecture, you're going to want something that syncs private and public. And a lot of the consortia right now are just working on private. And that's kind of those intranets, those AOLs, Prodigies, and CompuServes. Yeah, so we will have many of those entities involved as well. And we're in those discussions, and there'll be a monthly cadence of announcements of who's going to be involved shortly. It took somewhat of a Herculean effort just to get this off the ground, and now we're starting the onboarding process, and we'll probably start announcing our next tranche of membership mid-April. So what we've found specific to capital markets is they're self-selecting. So I can count on my hands kind of the subject matter experts that are really leading this innovation. There are probably 5 innovators and a lot of sheep following. And kind of the leaders like Alex Batland, Julio Fuara at Santander, those are 2 that just come to mind right off the bat. Amber Baldet and David Vole at JP Morgan. These guys are in the trenches driving. And they all know each other. And they're all good colleagues and friends. And they're using this as a forum to kind of start building kind of specific vertical use cases and deploying on that. So really what this started out as is we were just going to create this pretty spec at the protocol layer so each enterprise didn't have to tweak that. And we just found such a groundswell of interest in Ethereum for enterprises that we said, okay, well, we'll work on this. We'll have these genius PhDs work on creating that protocol, and then you guys, if you guys want to pick out use cases and work on it, go wild. And that's what we're going to start announcing. Every month, there's going to be a use case that we kind of go through and explain how we optimize it using this technology. So initially, it's funded internally, and then there are minimal administrative costs that are based upon the size of your entity. So there is a way to participate in this completely for free. There are kind of monthly calls, just like Linux Foundation is an open source foundation. And then there are kind of membership levels. So if you have less than 20 people, if you have 20 to 200, if you have 5,000 plus, it's X, Y, or Z. And I have those numbers, and we can go through. There's a membership team that onboards. Yep, and I can forward this. Sean actually has this deck, and he can forward it out and make this public. This is a groundswell, guys. This is a revolution. Thanks for participating. Cheers.
All right, let's give a round of applause to our 2 speakers for the night, Chris and Andrew. All right, so before we close off the event, I'd like to give thanks to those who made this event possible. One of them is Gaurang. Gaurang is the co-founder of Taurus. I believe he's somewhere upstairs there. So, as well as Vinay from ConsenSys Singapore. And the next meetup of the Ethereum Singapore one will be sometime in April. We're looking to bring someone from Melonport. Melonport is the portfolio management on the blockchain to speak at our event. So do leave a review and see you at the next meetup. Thank you. Have a good night.